Ever wondered what dy dx means in calculus? That's the question we'll be unraveling today. First things first, dy dx is a symbol that represents the derivative of a function. But what does that mean? Essentially, it's a way to capture how a function changes at any given point. Imagine standing on a hill. The steepness of the hill beneath your feet is like the derivative at that point. It may help to break down the symbol dy dx itself. The d in both dy and dx stands for delta, a term often used in mathematics to represent change. So dx signifies a tiny change in x, the independent variable, and dy represents a small change in y, the dependent variable. So when you see dy dx, think of it as the ratio of a small change in y to a small change in x. It's a measure of how y changes for each tiny step x takes. Consider an example. Suppose you have a function f of x equals x squared. The derivative of this function, represented as dy dx or f pi of x, is 2 times x. This means that for each tiny step x takes y, or the square of x, changes by 2 times the value of x. Output. But how do we find this derivative? This brings us to the concept of limits in calculus. To find the derivative at a point, we consider a tiny interval around that point and see how the function changes. We then let that interval become infinitesimally small. This limit gives us the derivative at the point. The concept of dy dx is also intricately tied to the slope of a curve. In fact, dy dx at a point on a curve gives us the slope of the tangent line at that point. This is why we often talk about derivatives in terms of slopes and rates of change. To summarize, dy dx is a symbol used in calculus that represents the derivative of a function. It measures the rate at which y changes with respect to x, or in other words, the slope of the function at any given point. It's calculated using the concept of limits by considering how the function changes over infinitesimally small intervals. Remember, whenever you see dy dx, think of it as a measure of change, a gauge of the steepness of a function's graph, and a tool to understand how a function behaves at any given point. And that's dy dx explained, a key concept in calculus that helps us understand and quantify change. So the next time you come across dy dx, you'll know exactly what it's all about.